Okay, so I'm going to go pretty quick through this, so hopefully this is something that's been completed and you're just checking your work. Below, is the following graph a function? The answer is no, because it fails the vertical line test. Okay. As far as domain and range, domain is the x from left to right, the x's from left to right. Now, from the left, if I come this way, this is the furthest point on the left, and that's when x is 2. Now, since I actually land on that spot, I'm going to use a bracket. And then since there's arrowheads over here on the right, this thing is going to continue this way for forever, which means there needs to be an infinity there. As far as range goes, you're looking from the bottom to the top. And so when you look from bottom to top, well, see that arrowhead there? It means it's going down for forever. So the bottom of this graph is negative infinity. And then the top of this graph, even though it looks like it might be stopping here, there is an arrowhead, and so it's going to continue to go up, so positive infinity. All right, cool. Moving on, I'm going to go a little faster on these. Is this a function? No, it fails the vertical line test. The domain from the furthest left to right is negative infinity all the way to this point, which looks like a negative 3. And I'm going to bracket that one. Same reasoning as number 1. Range is bottom to top, an arrowhead going up here and an arrowhead going down here. Tells me that it's going to be all real numbers. And so with interval notation, that's how you would write it. Okay. For each graph given below, graph its inverse on the other or over the graph provided. Okay, so an inverse is where you're going to switch the x's and y's. So I would probably just find like 2 or 3 good points that you cross at. Those are good. I don't know. We'll say that that's a good point. And I would just write them out. Like this is the point for negative 4. This is the point 2, 4, 6, 0, and then this is the point, like I'm going to call it 8, 8 because it's really close to 8, 8. And then for the inverse, all that you have to do is switch the x and the y. So the inverse points are going to be 8, 8, 0, 6, negative 4, positive 4. And then we just graph all of those. So it's still going to end up here. 0, 6 looks something like that, and then negative 4, 4 looks something like, nope, yeah, like that. So now what do? Well, now we just play connect the dots. And what this should look like is it should look like some kind of reflection of this graph. And sure enough, I mean, it really does. It looks like the same thing's just kind of been flipped up. And if you want to get technical, it should always look like it's been flipped across the line y equals x. So that should be its mirror image. Okay, and so the next one, I'm going to go much faster because it's the same thing. Find a few good points. I'm just going to use those two. Okay, that looks to be the point 2, negative 6. So 2, negative 6, and then 0, 2. So I'm going to flip those points by changing their x and y. So I need to graph the point 2, 0, and I need to graph the point negative 6, comma 2. And then I need to play connect the dots. There we go. Okay, and so that would be the inverse of that. Moving right along. Okay, find the inverse equation of the given below. So remember, that's just a y, and we're just going to switch x and y and then try to solve it. So it's just going to be x equals negative 3 plus 7/3 y. I would probably move that 3 to the other side first. And then in terms of getting rid of this 7/3, you could multiply everything by 3. And that'll get rid of that fraction for you, right? So it would be 3x plus 9 equals 7y. And how do I get the y alone? Well, I divide by a 7. So that would be my final answer on number 5. Number 6, same thing. This is a y. So I just need to switch the x and the y. I don't like this 5 in the denominator. I'm going to multiply everybody by 5. And when I do that, these cancel out, and this has a 5 over here. Now I'm going to subtract 25 from both sides. So it'll be 5x minus 25 equals negative y. Don't forget to recopy that negative that's in front of the y. And now to get the negative off the y, you're going to divide everybody by negative 1. And so when you do that, it just changes the signs. So it'll be negative 5x plus 25. Okay, and that would be your inverse. Okay, next one, it's going to be, I'm going to use x's and y's instead of n. Hopefully that's okay with you. X equals negative 2, negative y plus 1 minus 2. Ugh, this is ugly. Okay, let's add the 2 to the other side. And negative 2 over negative y plus 1. Okay, so I don't like these. These are a little bit harder. And when the fractions are this complicated, what I recommend you do is you go ahead and like stick this side over an invisible 1 just so you can cross multiply. Okay, so I'm going to cross multiply. I'm going to do the negative 2 times the 1 right here. Negative 2 times 1 equals x plus 2 times negative y plus 1. Then I need to get the y by itself, so I'm going to divide off the x plus 2. Boom, boom, divide off the x plus 2. And let's see what's left. Okay, now I've got negative y plus 1. So I need to subtract 1 from both sides. And when I do this subtract 1, I always put it behind the function. Now here they go away, right? But I'm going to put minus 1 back here. This equals negative y. Same thing as the last problem. We have a negative on the y, and we need it to be a positive y. So I'm going to divide everything by negative 1, and all that does is change the signs in front of each of these. Okay? So they're both negative, so they're both going to become positives. And that would be how I write my final answer. That was a hard one. It really was. All right, and then after the hard one comes the easiest one on the paper. Okay. Switch the x and y. Move the 1 to the other side. Divide by negative 2. And so your answer might be written like this. It might be written like this. I mean, these are the same thing if you break it up over the 2. All right, cool. So now we get to go down to evaluate the function. And if you're going to mess these up only if you do your arithmetic wrong. Usually people are pretty good about plugging in and they just mess up, negatives and stuff like that. So down here it's just literally telling you whatever's in the parentheses gets plugged in for x. So negative 4 times negative 6 plus 5, that would be a 24 plus 5 is a 29. Okay. Over here we are plugging a 10 in for any of the a's that we see. So 10 squared minus 2 times 10. What would that be? 80. And over here we're plugging all of this in for anywhere we see a variable x. So I'm going to use parentheses here. Since that's not just a number, use parentheses so it looks a little bit easier. And you're not done. You do need to go ahead and distribute. And then even after you distribute, if there's any like terms, put those together. So there's a 4 in the front and a plus 3 in the back. So I'm going to call this 7 minus 2y, or 2x. And that's how I would write my final answer. This one we're plugging in a 3a everywhere we see a variable. Again, use parentheses since it's not just a number, and that's going to help you when it's time to simplify. Because right now this whole 3a has a squared. You better square the 3 in the front and the a in the back. Okay? And then here you get to just multiply the 2 times the 3. And that's a weird answer, but that is the actual answer. All right, cool. So now let's go on to the second page. Okay, this is a little blurry, but it'll do. So we've got same thing, same directions as before. We're plugging all of this in anywhere we see a variable over here. See that negative? Make sure that negative stays, and then it's just t over 2 and then plus 5. And that's it. If that's a t. I think it's a t. If it's a 1 over 2, without the t, then you would need to put those together, but that looks like a t to me. Okay, over here, this looks like an n over 3, and we're going to stick it in anywhere over here that there's an n. And then for this one, you do want to do a little bit more work. Just multiply the 2 times the n over 3. So this is just really 2 over 1, and then you do top times top, bottom times bottom. And then write that plus 2 at the back. So that's it. State if the given functions are inverses. So on this one, you get to pick one of the functions, find its inverse, and see if it's equal to the other one, okay? I'm just going to pick the top one just because, okay? So I need to switch the x and y. Now, I don't like these 7s. Let me multiply everybody by 7 just to clear my fractions. So that's a nifty little trick there. And just make sure you put it on everything, right? So this x becomes a 7x, and these just drop the denominators. Okay, so I'm trying to get the y alone, so I need to subtract 12 from both sides. Then I need to divide by the -4. So be careful and make sure that your signs are good, your negatives and positives. So this is my answer. Now I need to compare this to what I see here and ask myself, are they the same? Well, if you take this part, it's a 7x over a -4. That does match that, right? And then I've got a -12 over a -4. What is -12 over -4? It is a +3. Yay! So they do match, okay? So just kind of dissect it piece by piece and see how good it looks, okay? All right, cool. So next one, same thing. I'm going to switch my x and y. So it'll be x equals -y minus 3. And then I'm going to move the 3 to the other side. And then I'm going to divide everybody by -1. And this is going to be -x minus 3. Okay, that looks absolutely nothing like the one below it, so that's a big fat no. They are not inverses. Okay. All right, so moving on, describe your use your transformation and the parent function on the board to graph each of the following. Well, bummer, there is no parent function on the board, so I cannot graph anything. This is unfortunate. Okay, so instead, let me see if there's anything else. I'll tell you what, I can't do any graphing or domain and range, but what I can do is make something up and then pretend that that was the same graph that you had to do. So I'm going to pretend that this was the graph of absolute value, except it stops at -2, 2, and +2, 2. So this is me pretending that this was the graph that was on the board, and I'm going to use this to do this problem, okay? So when you see this, you have to know your transformations. So what's happening is you should be learning terminology, like describe the transformations. If there is something inside the parentheses, it always moves left or right, and it's the opposite of what you think. So a -3 is going to move this right 3. And if there's a plus or minus on the outside, it is the up or the down. In this case, it's an up because it's positive. So that's what I'm going to do. I'm going to take this picture that I've made up and move it to the right 3 and up 2. And if you had a different picture, then just use that instead, because you will need to use that for domain and range. And in fact, I don't want to mess you up too badly, so I'm just going to do domain and range and the picture for this one, because you may be dealing with a completely different picture, and this is really all you're going to need to check with me on the rest of these problems. Okay, so once I moved the bottom of my graph, I moved it right 3 and up 2. I also moved this point right 3 and up 2, and this point up 3 and right 2, or whatever, right 3 up 2. And now I need to give the new domain and range. Well, now the domain starts at 2, and then on the right, it's going to end at 2, 4. Oh man, this thing is scaled by 2s, and I did not see that. Lame. Right 3, so really it should have been right 3 up 2 this way. I didn't see the graph. It's actually done by 2s. Boo. Okay, so then it's over 1, up 1, over 1, up 1, over 2. Yuck. This is not fun. Alright, so that would actually be my graph. Boo, boo, boo. And mine would go from 1 on the x-axis to 5. And my range is bottom to top, so it would go from a 2 to a 4. Now, notice, everybody, that I used brackets everywhere because it's a bracket if they're solid, right? If you land on them and they're solid. If you have any open circles on your graph, okay, be careful because if you have open circle, you need to use a parenthesis instead of a bracket, okay? Alright, so now I'm not going to do any more graphing or domain because I don't want to mess you up on your own picture, but let's just talk about what the transformations are. Over here you've got a 2 in the front of the f of x, and if it's in the complete front, it acts as a vertical dilation, and you might see the word vertical stretch. You might be able to say vertical dilation. I would say vertical stretch by 2 because that's the number in the front, and if that had been a fraction, you need to use the words vertical shrink, FYI, okay? And then we've got a -3. It's on the back of the function, so that's going to take this thing down 3 units. So make sure that you've stretched it by 2 and you've moved it down 3. This one over here, there's a negative in the front, and that is always an x-axis reflection. And then the -4, see how it's on the outside? So once again, it is the up or the down. In this case, down because it's negative. And the last one, here's what I was talking about up here earlier. There's a 1/2 multiplied to the front. So it's still a vertical dilation, but since it's a number less than 1, it's technically a vertical shrink. It's going to take the graph and make it wider. You know, it's going to shrink it down, and in turn it's going to look wide. Now I've got a plus, is that a 1? +1 on the inside, which means left 1. And then I've got a -3 on the outside, which means down 3. So you've got to review all your little list of the terminology. That's going to be very important. And once you know your terminology, you can just take whatever picture somebody gives you and graph it. Just move it like it says. After you've graphed and moved it, that's when you'll do domain and range. I would not do domain and range until the very end of the problem when you're looking at your final pretty picture. All right, that's it. Good luck, everybody. Let me know if there's questions.